Good morning, everyone. I would like to welcome you to HydroMediT 2024 Oral Hybrid Session, First Field Aquaculture. My name is Daniela White, and I am a postdoctoral researcher at the Department of Marine Sciences of the University of Aegean, and I chair this session with Dr. Vlachos Nikolaos. The presenters have 10 minutes for the presentation and 5 minutes for questions. Please turn off phones so we can begin. Allow me to introduce you our first speaker from our session, Ms. Malea Lambrini. Please, Ms. Malea.
Yes, thank you very much, dear Chairman. Yes, I will share my screen now. It's okay now? You can see the whole screen?
Yes, you can begin.
Okay. Yes, thank you very much. My name is Malea Lambrini, and the topic of our presentation is the development of a protocol for the cultivation of the brown alga Congolaria barbata and isolation of added value polysaccharides. The cultivation of the species in this presentation is referred to INTA systems. And why we are interested in integrating multicultural systems? Because first, they offer environmental sustainability. As the seaweeds that we use in INTA systems, they can remove nitrogen and phosphorus from water column. They function as biofilters, so we can have a higher quality production by improving water quality. Second, we have economic sustainability as they utilize the less natural resources, and also they reduce market risks from price stability. And of course, we have social sustainability, better healthcare, and nutrition. To meet our species here, Congolaria barbata is the most endangered habitat in the Mediterranean Sea. It is known also for forming dense forests, and of course, for its metabolites, secondary metabolites, we have antioxidant and antimicrobial activities. These polysaccharides are fucoidants and alginates that are used in food industry, pharmaceutical industry, and cosmeceutical industry. So the cultivation of Congolaria barbata is a very good option for future exploitation of the species under INTA practices. So the purpose of this study was whether Congolaria barbata strain of our region could be isolated and unialkali cultivated all the year. Second, the optimum temperature for photosynthesis and growth of these species. What are the optimum salinities for growth? Also the yield of the added value polysaccharides, and the possibility of achieving the cultivation in tanks using the RAS units of the hatchery. Now, as it refers to our methodology, we cultivated unialkali the strain of Congolaria barbata under controlled conditions of temperature, irradiance, pH, and salinity. We used for growth medium the phosphorus, and one amount of this plant material, algae material, was used from us in our laboratory to carry out the temperature and salinity experiments. Another amount was sent to our colleagues in Athens to make the isolation and characterization of the polysaccharides, and another one was sent to Kefalonia fisheries to make there the outdoor cultivation of the species. So in experimental design, we collected 36 upper tali, and we pre-acclimatized them under steady control conditions of temperature, salinity, irradiance, and pH. The growth medium was renewed daily, and to avoid the medium stratification, we used shakers under the small jars. And the total experimental days for both experiments was 15 days. Now, a temperature experiment, we have 6 conditions from extreme low temperature of 5 degrees Celsius to extreme high temperature of 30 degrees Celsius. We make RGR measurements, relative growth rate measurements, and oxygen productivity measurements under irradiance, salinity, and pH condition, which were monitored daily. Also, at salinity experiment, we have 4 conditions from 25 to 40. Here we made RGR measurements and under irradiance, temperature, and pH steady conditions, which are also checked daily. Now, as it refers to our results, we observed Ancocolaria barbata presenting the higher growth between 10 and 20 degrees Celsius. Also, the extreme low and high temperatures affected both photosynthetic performance and relative growth rate. Also, the reduced photosynthetic efficiency at 5 degrees of Celsius was due to disruption of oxygen evolving complex at the donor site of photosystem 2. And these temperatures, extreme low temperatures, are not very often in the Mediterranean Sea. And also, respiration rate was affected by these extreme low temperatures due to damage of mitochondria structure. At extreme high temperatures, respiration rate and photosynthetic rate were the highest. As you can see, these temperatures are very common phenomenon in the Mediterranean Sea due to heat waves during summer. Also, we have the higher respiration rates as they alter the activation of rubisco. Also, we have the highest photosynthetic respiration rates under increased temperatures, and this higher energy which was invested in respiration rate, it wasn't enough for species growth performance. So we observed that at highest temperature conditions, we have the minimum RGR values of the species. At salinity experiment, the Ancocolaria barbata strain has a higher growth between 25 and 40 salinity. The higher RGR values were observed at 45 salinity, and this is a proof that this species can be detected also at lagoon habitats. And at the highest salinity of 40, we observed the minimum RGR values due to the inhibition of growth as it was difficult to intake and assimilate the carbon dioxide. Now, the results from our colleagues in Athens, they had the application and of accepted isolation protocol. And we have the isolation of 2 types of polysaccharides that were both coidans and sodium alginates. And the isolated yields that they found were similar to the ones who are reported in the literature for these wild populations of the species. Also, the results from our colleagues from Kefalonia, the best cultivation period in seawater enriched media and in instant tanks, there was between November and June of 2022 and October to December, because as we saw previously, the very high temperatures at summer have a negative effect of growth of the species. Also, they observed that the land-based cultivation outdoors, they are very successful but inferior to the enriched seawater. And one reason is maybe to the fluctuation of the RAS influence or to a lesser amount of trait elements. So to conclude, we thought that Ancocolaria barbata strain presented the best growth between 10 and 20 degrees of Celsius. The low temperatures, which are not very common in the Mediterranean Sea, affected negatively growth performance, respiration rate, and photosynthetic performance. On the other hand, the high temperature at 30 degrees of Celsius affected both photosynthetic efficiency and growth, which were very high. And these temperatures are very common in the Mediterranean Sea during summer. Also, we have the highest respiration rates at extreme high temperatures, which led to lower growth performances due to higher energy survival cost for the species. Also, the highest growth performance was detected between salinities 25 and 35. The species was tolerant to salinity 25, and this can explain its presence also in lagoon habitats. Also, we have the successful
1
isolation
minute
and
left.
yes, and characterization of added value polysaccharides, fucoidans, and aldehydes, and also the successful cultivation in land-based tanks following the NIMTA practices, all year except from summer. Thank you very much for your attention.
Thank you, Ms. Malea, for the excellent presentation of your work. Now we have 5 minutes for questions. We don't.
I don't know why, but I can't hear you.
Okay. Moving on to our next speaker, Ms. Kurkova. Can you please share your screen?
Yes, of course. Good morning, everyone. I hope you see my presentation. The topic of my presentation is the effects of endogenous and exogenous factors on hematological parameters of fish. Hematological analyses are commonly used to evaluate fish health and welfare in aquaculture, veterinary practice, and scientific research. Hematological parameters were proved to be highly sensitive to various environmental factors, including nutrition, water quality, stress, or pathogens. Peripheral blood tests involve measurements of various red and white blood cell indices and are often supplemented by biochemical analysis. The use of the hematological techniques is arduous and requires experience, but the high amount of information and the relatively low cost are considerable advantages. Manual hematological methods that are most often used in fish hematology do not require highly specialized laboratory equipment. However, automatic analyzers adapted for use with fish blood are also in use. The results of hematological analysis may be affected by various pre-analytical and analytical factors. The aim of our study was to review and summarize the data obtained by various authors concerning hematological methods used in fish, taking into consideration various factors that may affect the results, and to formulate the recommendations to a practical guide for scientists to help obtain reliable and reproducible results. Moving on, hematological examination is one of the methods most commonly used to evaluate fish physiological status and health. Routine hematological analysis include evaluation of blood cell counts and other cell-related parameters, as well as measurements of biochemical indices, such as plasma compounds. Red blood parameters include, as we can see here in the picture, erythrocyte count, hemoglobin concentration, hematocrit value, mean corpuscular volume, mean corpuscular hemoglobin, and mean corpuscular hemoglobin concentration. On the other hand, white blood cell parameters include leukocyte count and differential leukocyte count. In the next picture, we can see that many factors can affect physiological and biochemical markers of fish blood. These factors may be divided into two categories. The first category is the internal factors of the fish itself, and the second category is the external factors of the environment required for fish survival. The endogenous factors are related to the genetic and physiological condition of the fish. For example, sex, age, and reproductive cycle. The exogenous factors are in diet, disease, season, temperature, salinity, activity, stocking density, and dissolved oxygen. Now, moving on, the results of hematological analysis in fish depend on many intrinsic and extrinsic factors, such as fish stress level, method of blood sampling, pre-analytical factors such as anticoagulant use, in temperature and time of storage, and analytical procedures including type of diluent and correctness of blood cell classification. Moving on to the materials and methods, for the realization of this study, an extensive search of articles related to the subject was carried out. For this reason, keywords related to blood collection methods were used in combination with other terms such as aquaculture methodology and others in databases such as Scopus, PubMed. In total, 400 documents were considered relevant to the research subject and finally evaluated. The collected data then was processed with the help of the Excel program. The following results were obtained from these 400 articles. These were evaluated, and from these 102 were deemed appropriate and proceeded with the help of the Excel program. Data from these articles were tabulated in a table which reviews the analytical factors and evaluated parameters in fish hematological studies, as we can see here in the picture. And from this table, the following diagrams emerge. In the first diagram, we can see the percentages of sampling methods during blood sampling. As we can see, the highest percentage was the cardiac puncture method with a percentage of 20.6, and the smallest was the blood collection from the branchial arc with a percentage of 1%. The sampling methods also that were used also was cardiac puncture, caudal severance, venipuncture, and branchial arc blood sampling. In the next diagram, where we can see the percentages of the anesthesia used during the blood sampling. Anesthetics that were used were 2-phenoxyethanol, evenol, benzocaine, MS-220Q, 22 HydroMediT, clove powder, ice, thiamyl alcohol, and stand. From these, the highest percentage was MS-222 with a percentage of 27.7%, and the lowest was HydroMediT, clove powder, thiamyl alcohol, and stat, which are mentioned in the other category because they all had the same percentage. Moving on to the next diagram, which it's about the diluents. Here, the diluents used were Hayem, Turk, Nut Herring, Daisy, PPH, Automated, WBC diluent, Prozac Scrubber, Growers, Semi-Automated, Commercially Available Dilution Solution, Toisson, RBC Diluting Fluid, and Marcano. The largest percentage was Hayem with a percentage of 32.8%, and the smallest was Growers, Semi-Automatic, Commercially Available Dilution, Toisson, RBC Diluting Fluid, and Marcano with a percentage of 1.6%, which are also mentioned in the other categories we can see here. And the last diagram, which is about the anticoagulants. The anticoagulants that were used were heparin, EDTA, and citrate. The highest percentage was heparin with a percentage of 65.9%, and the lowest citrate with a percentage of 1.2%. Moving on to the discussion, we begin with the anticoagulants. We've seen that the heparin is the most preferable for the fish species, but also EDTA is suitable from some fish species. Appropriate concentration of an anticoagulant is also important. Therefore, concentration of anticoagulant should be minimized and equal for all blood samples. The results of this study also show that if the fish are healthy, unstressed, and the blood sample is taken quickly, anticoagulation is not necessary, and heparized needles alone may be sufficient without any anticoagulant in the sampling tubes. Moving on to the diluents, they generally did not affect the blood cell count, but all the cells, including leukocytes, were best seen in blood that was diluted with colorless isotonic high-M solution than in adhering ordaces, because as we can see here in the picture, the dyed the nuclear of the cell is blue. Now moving on to the anesthetics, we see that the anesthetics affected the biochemical changes in blood values. So therefore, anesthesia should be used only when necessary, and pilot tests should be performed to select its appropriate dose and time appropriate for each specific species and body size. Also, water quality should be taken into account, as temperature, pH, or concentration of nitrogenous metabolites may affect the action of the anesthetic. Finally, the results show that cardiac puncture is the most commonly used method of blood sampling from fish, followed by caudal venipuncture, while branchial arc sampling and caudal severance are rarely practiced as they involve the death of the fish and may cause contamination of the blood with bodily fluids. The results also showed by Borzarsky et al. In 2018 showed that venous blood has significantly higher hematocrit, hemoglobin, and RBC count compared to cardiac blood. Borzarsky et al. Also in 2021 showed that RBC count was higher in venous blood, while hematocrit, MCV, and MSH were higher in the cardiac blood. In conclusion, hematological analysis of peripheral blood is an inexpensive and very useful tool for evaluating fish physiological status and health. Some of the hematological parameters are very sensitive to the changes of the environmental factors and provide information about physiological disturbances before the development of their external symptoms. All pre-analytical and analytical factors may affect these results. Therefore, experience is necessary to obtain reliable methodological data. We could summarize our recommendation as a guideline for scientists. Consider appropriate number of replicates while designing an experiment. Try to reduce stressing fish as much as possible. Consider the use of anesthesia in fish highly susceptible or inevitably exposed to stress. Use appropriate anticoagulant, preferably heparin at appropriate concentration. Select a method of blood sampling to obtain the required amount of blood as fast as possible. Preferably perform analysis immediately after sampling. Select a diluent for RBC and WSU counts. Isotonic colorless solutions allow easy counting, such as HAM. Each parameter should be measured in all the samples by the same persons to eliminate mistakes by the observer. Carefully identify blood cells using various searches for comparison and evaluate as many parameters as possible to obtain extensive information. This work is a part of my dissertation for the MSH Aquaculture in Mediterranean Aquaculture. Thank you for this is my bibliography. Thank you for your attention. Are there any questions?
Thank you, Ms. Kurkova, for the interesting presentation. Now we have 5 minutes for questions. So we don't have any questions. Please stop sharing your screen. So we move on with our next presenter, Ms. Karathanu.
Good morning, everyone. My name is Irini Karathanu. I'm an ichthyologist, and we will say some things about planning, management, and implementation of aquaculture tourism. So let's meet the parents to break the ice. So these would be the parents of what is going to be called aquaculture tourism, any form of marine tourism activity, and let's say a fish farm. So what would aquaculture tourism be like? We thought about it and we talked about the perspective from the aquaculture side and the perspective from the visitors. So the aquaculture perspective is that a unit, a facility is finally allowed to have visitors. And the visitors' perspective is that they can actually approach and see for themselves the function and maybe interact with some of the production stages. So basic key point for those two are that we finally have visitors in the aquaculture farms. And how would we do it? So we should first define a target. And if we see a little bit figure number 1, the lead objectives for accomplishing the target of successful endeavor on aquaculture tourism for a fish farm, those have to be related with some social aspects, some economic aspects, and environmental aspects, and of course, national legislation, if not communal, that we will discuss in following. So in order to achieve a balance between social acceptance, consumer awareness, and the integration of the aquaculture in the community, the environmental service now that should be by independent certified bodies and the national legislation as well. If we want to accomplish all of those things to mix somehow the tourism activity and the aquaculture activity, we should definitely plan it very carefully and of course manage it in a viable way for the farm. But how would that look like? So we thought about 3 different approaches. How would a tour be? So it could either be an onboard tour or an underwater tour because people are interested to see what happens in the sea cages. Most people, when they think of fish farming, they have just the sea cage production part in their minds. So that's the most interesting thing for them to see. So we can either show it to them by boat, or if they want, they can dive in it, or maybe a little bit of both. That would be a third approach, a combination of both. So each interested aquaculture unit has to decide that beforehand, what kind of entertainment they're going to offer. And the planning strategy will be based exactly on this decision. So this is the number 1 decision, we could say, in order to switch from pure production that the unit is accustomed to also entertaining visitors. And the best way to decide that is consider the particular characteristics of every unit, the location, landscape and seascape, the type of production, the size of production, the capacity in total. So all those aspects, and of course, never neglecting the budget, the how much it costs, which is the decision point, are to be carefully concerned before choosing which type of entertainment we will provide to visitors. And so let's say that we did choose carefully which type of entertainment we want to offer, and now we have to plan for that. How would that be? A SWOT analysis is what we recommend. I think it goes with everything, every field. Everyone knows their strengths, weaknesses, opportunities that aquaculture tourism might cause threats, maybe, some pros, some cons. And then, of course, are the licenses required? Is there a specific law? And if so, is it national? Is it communal? Is it Mediterranean? Do we have it? Do we not? What licenses do we need? From which people? I mean, which authority is going to give us those licenses? And of course, the safety measures protocol. Now we have people that are not familiar with the aquaculture and the fish farm wandering around the farm, both in land and water. So safety measures should be particularly designed just for the visitors. And all those having people around requires modifications. So what modifications would we need? And do we need additional equipment? Do we have to hire extra personnel? All those are planning stages that we have to consider in order to transfer from pure production to also aquaculture tourism. And definitely How is people going to know that this particular fish farm engages in aquaculture tourism? So promotion and visibility actions, how are we going to bring that to people? How are we going to communicate that? So this is also a part of the planning. And definitely, again, we come to the budget and re-examine if this endeavor is profitable or not. So let's say that we did choose our type of entertainment, we planned it very well. How do we keep this viable in the long term, and how do we run the business? So we have to consider how are we going to do things? How many of what do we need? How many of equipment? What type of equipment? Are those things that we will buy frequently? Are those investments that we will do once? What kind of personnel? What background do we want them to have? Will we have them full-time? Will we have them during the touristic season? Will we have them part-time based on the tours that we have booked? What is the schedule, the time schedule for the aquaculture tour? And what is the plan in general from start to finish? And how do we balance that with the pre-existing function just because we expect tourists to be present in the touristic season? And this is harvesting season for many farms. So how are we going to combine that? It's a lot of work. It's at the peak of the production, and we also entertain guests. So this has to be carefully considered. And since well-being and hygiene are key ingredients for a successful aquaculture facility, we should probably consider having cages for demonstration purposes only, not to mingle the visitors with the production cages, the ones that are going to go to the market. So the theory was nice. Now you will say, Irini gives us some examples. So I have distinguished 4 examples here between the planning and managing stages, just as indicators. I am free to discuss everything in the questions part. So we're thinking about having guests, having people over at the facility for some hours. So they definitely need toilets. So we plan about having sanitary spaces exclusively for the visitors, showers and changing areas if they scuba dive. But if we come realistic, do we have the space? And do we have the money? And do we have the time? And do we have the licenses to do that when we want? Sometimes we do. Lucky. Sometimes we don't. So smart at that point. We have to think. So managing would be, how about installing composting toilets as a first step? And also those could be an eco-friendly way. So that could be a good message for people as well. And what about gathering people? That would be example number 2. So we need an assembly area to gather the people. And we didn't need that before. I mean, everyone knew their own job and they just went to do their tasks. So how are we going to welcome them, gather them? What happens if we don't have a collection point in case of emergency? So managing would say, okay, so let's make it a cafeteria because it's warm outside, it's summer, people need refreshments, and how about welcoming them with something like that? Refreshments, light snacks, they might have kids, they might get hungry, and why not introduce them to how the aquaculture works with maybe a video wall and some speakers, just employ technology to just make them feel a little bit comfortable and somehow introduce them to what they're going to experience. And then it's the boat tour part or the diving tour. And what if someone doesn't want to dive? So here comes management again and says, okay, install some underwater cameras. Some facilities already have those, and connect them live with video screens on the boat. Or why not have a glass bottom on the boat? And maybe the group would be lucky enough to witness some species, some wild fauna that comes in the aquaculture. And some of those species are very exciting for the public to see. So why not implementing that? And definitely, of course, is the safety protocol. We mentioned it a little bit earlier as well. So how we do that when it comes to managing the endeavor? Pharmacy area, why not have a certified nurse, even part-time? Or why don't train the tour personnel with first aid? We know that aquaculture is far away from hospital, far away from medicinal centers. So we want people to feel secure when they visit, that if something goes wrong, they might have someone there who knows what they're doing. And let's see the steps of a tour. So how would it be? We called it figure 2, start to end pathway of an aquaculture tourism tour. So what would the pathway be? from starting point to the finish line. So first it will be gathering them in the lounge area or gathering area or cafeteria area or whatever, treat them maybe with something, the video wall presentation, the tour to the facilities, and then it's the boat tour on the sea, scuba diving, if we do, if we want, if they want, if we have it, if not, the return to the shore. Why don't we give them a small souvenir for marketing purposes, for communicational purposes, just to have something with them when they leave us? And then, of course, they should definitely try the products of the farm. This remains a fish farm. It doesn't matter if now it has visitors as well, but it's not a touristic business. It is a business that produces food, and they should be somehow engaged in that kind of food. And of course, don't leave people go out without providing some feedback. And that would be better after reflection. So provide them with a way to give you feedback, not right away at the spot when they're tired and hot, but just when they are back. When they're back and have thought a little bit about it. And that would take us to the finish line. I'll skip the pros and cons, and I'll say just a little bit here. Why would we go for it? Would we, I mean, the aquaculture farm. It's a win-win for everyone. Aquaculture wins, tourism wins, socioeconomic development in the area. The public understands that it's complex and important to have aquaculture nowadays. And also they can see that they can be eco-friendly businesses. I mean, because there's a lot of discussion around that. And the aquaculture, since someone now is watching, they can alter their ways to more sustainable way of function. And people also can familiarize themselves with the product. So they actually gain more customers in the future, which are all beneficial. And the disclaimer, and this is where I'm done. So this work was a part of a course, of a master course, not a thesis yet. We're trying to make it a paper. I mean, there has been some time since its submission here to HydroMediT, but we need further exploration, of course. We did it because in Greece's national plan for the development of aquaculture, they want to introduce aquaculture tourism activities. So it's something that has been talked a lot nowadays. And we don't want to cause any conflict with the fishing tourism activity that has been active in the country since 2015. We try to distinguish that exactly by providing this tool, different experiences, different opportunities and references. And thank you very much for your attention and patience. Thank you.
Thank you, Ms. Karathan, for the excellent presentation. Now we have 5 minutes for questions.
Yeah.
Okay. Thank you. Thank you for the excellent presentation. Have you tried some of this on the field with, or it's for the time being just the theoretical framework? This is one question, just to finish all together. And the other is other information, mainly that before 1 month, we have changed the Greek legislation. So now the auxiliary vessels from the fish farms, they can also involve in fishing tourism activities and aquaculture tourism. So it will be easier for the movement of the tourists and to be in a full package together, maybe with fishing vessels, with some tourist operator, because it will be easier to be in the farm and move around the cages and not just dive in the vicinity of the cages. And the other one, it's a very good the way that you present the time flow, and it's easy for a company to understand that. And especially about what have you said, it's not good to mix the production cages with the cage. But have you think some ways to present to the farms on how they can involve more the tourist activity? You said about the restaurant, but with the local taverns, it's not easy for a fish farm to have their own tourist or accommodation facilities because of the licensing. But maybe it will be good to have a few examples on how they can work with the local businesses to have the accommodation of the tourism in the local taverns and restaurants or small hotels. This altogether.
Okay, thank you very much, Dr. Hadjieftathiou. I'll start with your first question. That framework is actually just because we have one example in Rhodes, currently in Greece. So there is a fish farm that is now running under a different name just because of the legislation mixed up there. And they have been trying to introduce people to aquaculture tourism, to touring them actually within the aquaculture facility or close. So this is where we got our inspiration. And just because, I'm going to the second part now, the legislation has been talked for some time now and has been actually implemented, as you said, a month ago. We tried to provide some pathway that is, of course, customizable, depending on the unit, depending on the farm, depending on the particular characteristics, let's say, of every situation. Your third point is very interesting because it's exactly what a full paper would describe as well. The collaboration between the fish farm and restaurants, or even between the fish farm and some bus companies. We don't expect tourists to get there on their own cars. Maybe there should be a bus company that would actually gather them and take them to the facility, and of course, take them back. So we talk about transfer, and we talk about also having the products of the farm taste in a local fish tavern that they would be collaborating. So those are aspects that we're actually thinking of. Just because of licensing, as you said, and maybe space and area and costs. I mean, we cannot just tell to people what they're going to do. Of course, it's customizable. And the step-by-step pathway could start from not just when they gather to the assembly area of the farm. They could start from when the bus company collects them and to transfer them to the aquaculture, or the part where they taste the food or the products of the farm. We could have a little more stages, maybe. The bus takes them to the tavern, they taste the products there, and then returns them back to their hotels or whatever. So, yeah, any other questions? Mr. Klaudatos.
Ms. Karathan, congratulations for the excellent presentation. Just a couple of
Mr. Lolas, please stop sharing your screen.
A couple of brainstorming ideas that I came up with. Maybe it will help you with your publication. Have you considered basically the visitors to visit like pre-growing installations or a hatchery, or a fish feeding factory?
Mm-hmm.
And how would you tackle with corporate espionage?
Okay, so yeah. Let's say that, okay, I'll start from the first observation. Yes, indeed, people can also, when I said tour the facilities, I meant whatever facilities on land before going to the sea cages the fish farm has, or even if collaborators of the farm are open to the idea and can be licensed, of course, so that this is a legal and safe procedure. So people can actually visit all the different stages of production. And second, but this is still customizable, of course. And corporate espionage, this is something that we haven't thought about really, just because maybe so far is one example in Greece. But this is a very good point to investigate further, especially because people who would have an idea of how to implement something like that, how to plan it and work with one farm, they would be the other farms would be very interested to employ them, and they should be able to provide a different plan, just not...
Or pose as tourists.
Yes, of course, and tourists as well.
But if you manage to do the touristic...
Please, Ms. Galogianni, stop sharing your screen.
In land installations, this would vastly simplify the logistics. So it would be an added value point to have people visiting land installations
Yeah.
instead of sea installations.
Definitely. And it would be a little bit safer, maybe, even.
Yeah,
So it would make things more...
Do it in parallel,
practical.
basically, but just another way to think about aquaculture tourism.
Great points. Thank you very much.
So thank you, Ms. Karathanu, for your excellent presentation.
Thank you very much.
We are moving ahead with our next speaker, Mr. Alexios Lolas.
Good morning.
Mr. Lolas, please share your screen.
Can you hear me?
Yes,
Okay,
we do.
perfect. So I was raising my hand previously. I wanted to ask a question to either Mr. Karathanu or Dr. Hadjistathio if they can share the number of the new legislation about aquaculture tourism, just to know if they have it available.
Mr. Lolas, you can send me an email.
Yeah, okay.
And I'll forward you the new law.
Thank you very much. So, good morning, everyone. Thank you for your participation, and also let me extend my thanks to the organizing committee for allowing us to perform this presentation online. Unfortunately, we couldn't be able to be present there. So, let's start by a small introduction. Let's see. Okay. So in agriculture, acidic soil is a significant issue because it affects plant growth, nutrient availability. So improving the soil pH is crucial for enhancing soil fertility and also crop productivity. Now, there is a process called liming where we add calcium carbonate or similar compounds to the soil. So in order to raise the pH, thus reducing the acidity and optimizing the productivity and ensuring a healthy crop growth. However, calcium carbonate, dolomite, and other liming materials often need to be mined, processed, and transported over long distances. So this contributes to high costs, and also they have a very high environmental impact. So exploring more sustainable and locally available materials, such as agricultural waste products, for example, or industrial byproducts, and to find innovative soil amendments could reduce costs and minimize environmental impacts. In this context, sustainable aquaculture practices are essential for minimizing these environmental impacts and also ensuring the long-term viability of marine resources. A key aspect for sustainability is the concept of circular economy, which emphasizes in reducing waste and making the most out of the resources used. So by finding innovative ways to utilize byproducts from aquaculture, we do not only reduce waste, but also we can create products with added value. Now, this was the idea, and in this context of cyclic economy and sustainable aquaculture, we examined the use of the Mediterranean mussel, Mytilus galloprovincialis, cells, as a byproduct of aquaculture, but also the food industry, to use it as a potential liming material, as a source of calcium carbonate. What we did is we collected the soil samples from a local area here in Volos, in Magnesia, which is known for the acidic soils. We measured the pH of the soils there, and for our experiments, we used the one for the lowest pH. The mussel cells were provided by a seafood processing company, and they underwent a process involving rinsing them with distilled water and air drying them in an oven for about 24 hours, about 40 degrees Celsius. The dried material of the dried mussels were then ground into with a mortar and a pestle, and the powder that was produced was sieved through a 2 millimeter and a 1 millimeter stainless sieve in order to obtain two different grain sizes. The lowest one, we called it fine, the ground powder, fine powder, and the one between 2 millimeters, we called it a coarse powder. The experimental setup was conducted in the campus of the Department of Ichthyology and Aquatic Environment. We used experimental pots. Each type of the ground mussel cell, grain size, coarse and fine, was used as a treatment in 6 different ratios. Specifically, 4 kilograms of soil was mixed with 4, 12, 20, 40, 120, and 240 grams of fine and coarse powder. This translates to 0.1, 0.3, 0.5, 1, 3, and 6% of ratio between soil and the amendment. And we also used an untreated pot which was designated as the control. The pots were watered every 3 days, ensuring that soil moisture was maintained at approximately 65%. And for the pH value measurements, small samples were extracted from each pot at intervals of 30, 60, 90, 120, 150, and 108 days. This means 6 months, the experiment ran. Now, what did we find? The selected soil was characterized as clay. The initial pH of the soil and the control sample was 4.26, really low, very acidic. The organic matter content was 1.21%. The available phosphorus 23 milligrams per kilo of soil, and the exchangeable potassium 120.9 milligrams per kilo. From our results, it seemed that all the ratios we used resulted in an overall raise of the soil pH as expected, because, okay, we added a compound that has lots of calcium carbonate. Remarkably, the 3% and 6% ratio of the fine powder showed very quick increase, whereas the coarse powder also the 3 and the 6% showed a quick high pH increase, but in a smaller ratio. It took longer to reach the neutral value for pH. Now, organic matter in all the applied doses increased with application of the mussel cells powder. The highest values of organic matter were achieved in the 6% ratio. For the fine powder also displayed higher values, 2.27%, whereas in the coarse powder, 2.09. And the same pattern was observed in the other parameters we measured, the available phosphorus and the exchangeable potassium. Again, the 6% ratio displayed the higher values. Now, in conclusion, it seems that from our research, from our study, mussel cells can be a promising liming material in the agriculture sector. Our findings indicate that they effectively increase soil pH, organic matter, and key soil nutrients, making them a viable amendment for acidic soils. This approach not only supports the sustainable aquaculture concept, but also aligns with the principles of the circular economy by transforming something that is considered a waste into a valuable resource. And also, furthermore, our research demonstrates the benefits of a multidisciplinary approach where we integrate various scientific fields to achieve sustainable aquaculture and agriculture practices. And in regards to future prospects, we already have started testing with plants in order to understand the broader impacts of processed muscle cells on plant growth and health, not just the soil. And also, we are thinking about using other byproducts of the aquaculture or the food industry, which contain calcium carbonate, such as probably sea urchins, which, okay, they're not an actual aquaculture product, but they are a target for artisanal fisheries, and there is the byproduct of the cells, and also snails, for example. So thank you very much for your attention, and I'm happy to take any questions you might have. And I hope I didn't tire you.
Please stop sharing.
Yeah,
thank you, Mr. Lolas, for the interesting presentation. Now we have 5 minutes for questions. Yes, please.
Good morning, Mr. Lolas. I want to one question is, have you estimate how many tons of cells from muscles are the waste that annually produced? And the second part is, have you been in contact with an industry, a company that can turn this to this, the soil product that can use? And how many tons of these are needed for the production in Greece? This is asked for also from my background with waste reuse, with the circular economy, because I want to understand if the commercial possibilities and the applications of this very interesting work. Thank you.
Yeah, thank you for your question. In fact, it's difficult. We came in contact with 2 or 3 industries, and one of them provided us with the cells. We also came in contact with local Tsipuradica. If you know, here in Volos, it's very common to this kind of tavern. So they have many mussels as a waste. I cannot give you a precise number, because and also I'm trying to answer your other questions. We are now in the process of, we applied for a research grant to explore further this, and to collaborate with a manufacturing company with sea cells, and also one company in northern Greece which processes waste materials in order to use them as fertilizers. So we will have precise numbers later on, but not now. I cannot provide you with numbers, but if we take the grant, we will have results.
Thank you, Mr. Lolas. Do we have any more questions? So we are moving on to our last speaker from our section, Miss Elena Galogianni. Please, Miss Galogianni, share your screen, please.
Hi, everyone.
Hello.
Can you see my presentation okay?
Yes, it's okay.
Perfect. So, hi everyone, I am Elena Galogianni, a PhD student from University of Thessaly in Volos. And this presentation is about a part of my PhD. We all know that one of the high priorities of the aquaculture sector towards sustainability remains the search for suitable dietary alternatives to fish meals and fish oils in aquafeeds. Microalgae are promising candidates that could reduce the dependency on fish oil and fish meal. and lately have attracted strong research and business interest. But why are microalgae considered such good alternatives? Well, depending on the species and culture conditions, microalgae can contain high levels of proteins with a good amino acid profile that fits the fish requirements. In addition, certain species can contain high lipid content with significant amounts of the essential polyunsaturated fatty acids, such as EPA and DHA. Plus, they can contain several bioactive compounds, such as antioxidants and pigments. Microalgal production can support significant expansion by farming on non-arable land by recycling nutrients from using seawater and wastewater. They have a higher photon conversion efficiency, CO2 sequestration, higher growth rates, and thus larger biomass yield than terrestrial plants. So it is quite clear that their use in aquafeeds holds a potential to increase the eco-efficiency of the sector in case their market supply becomes economically feasible, which has been an issue in the past. But first, it's necessary to investigate which species are suitable to aquafeeds, to what extent they can replace fish meal and fish oil, and how they might affect the nutritional quality of farmed fish for human consumption. And so, among the several species, Chlorella vulgaris is one of the most common microalgae that can be easily grown, has a high protein content and growth-promoting effects, but still has not received adequate information in fish nutrition. Chlorella sorkiniana is also a single-cell species that can contain high levels of protein and essential amino acids, and therefore should be a promising fish meal substitute. However, not many studies have been using this species, and so the information is quite limited. So, in this context, the present study was conducted to evaluate the suitability of these two species in the diet of sea bream and assess the effects of fish meal substitution on growth performance, whole body and muscle biochemical composition, and muscle fatty acid analysis. So, the tested microalgae for the experimental diets were both pilot-produced and commercially available products. Specifically, we examined our own cultured Chlorella sorokiniana, which was grown in open ponds under photoautotrophic conditions in the University of Thessaly, with a protein content of 48.7%, compared to commercial sorokiniana, which had a 37.7%. We also used Chlorella vulgaris with a 54.6% protein. And the fish meal that we used had a protein of about 65%. Now, 7 isonitrogenous and isoenergetic diets formulated in order to satisfy the requirements of sea bream and to simulate commercially available diets. An algae-free diet was used as a control, containing 20% fish meal, while a second diet was formulated to contain the sorokiniana meal that was pilot-produced, replacing the fish meal protein of the control diet at 20%, corresponding to 54, give or take, grams per kilogram inclusion level. In the diet CS20 and CS30, the fish meal protein of the control was replaced at 20 and 30%, respectively, by a commercial sorokiniana meal, corresponding to 70 and 104 grams per kilogram dietary inclusion levels, respectively. The remaining 3 diets, CV20, CV30, and CV100, were formulated to contain commercial Chlorella vulgaris meal and to replace 20%, 30, and 100% of the fish meal protein of the control corresponding to 48, 72, and 240 grams per kilogram inclusion levels. So the diets were pelletized by a California pellet mill to produce pellets with 1.5 millimeters diameter. And for the trial part, juvenile sea breams of 2.6 grams initial mean weight were distributed to 21 closed seawater circulation system tanks of 125 liters capacity. Fish were divided into 7 dietary treatments in triplicates. They were hand-fed to alpine satiation twice per day for the duration of 3 months. After the 90 days, fish survival was high and similar among the groups, and very few mortalities were observed. Regarding the feed intake, measured as grams per fish, it was similar in all groups when compared to the control. However, it is worth mentioning that the CS30 group had the highest value. Furthermore, a decreasing trend was observed as the inclusion levels of Chlorella vulgaris increased, with the 700 group having consumed the least amount of feed, which denotes a maybe lower palatability of vulgaris compared to fish meal. While that was the case for the feed intake, the opposite trend was observed in the daily feeding rate, with CV100 group having a significantly higher rate compared to both the control and the CV20 group. The lower feed intake led to a significantly reduced fish growth performance in terms of both final weight and specific growth rate. On the contrary, the commercial Serokiniana fed fish had the highest final body weight and SGR, but not significantly different than the control fish. Regarding the feed conversion ratio, all groups had similar and low FCR values, and it might not have been statistically significant, but the CS20 group had the lowest one. On the contrary, the FCR was significantly higher for the CV100 group and was also increased in the CV30 group. To add to that, the protein efficiency ratio appears to be significantly lower in the CV100 group and highest in the CS20 group. However, again, not statistically different than the control. Both protein and lipid retentions were significantly affected by the diets. In particular, the CS20 group had higher protein retention than the CV30 and CV100 groups. However, all groups fed either Serokiniana or vulgaris had similar values to that of the control group. Additionally, the CS20 and CS30 fish had significantly higher lipid retention than all the other fish, which had similar values among them. The whole body and muscle tissue biochemical composition analysis revealed no significant differences among the experimental groups, which indicates that none of the Chlorella species dietary inclusion affected the macronutritional value of the fish. And now for the fatty acid profile. First, with the diets. In general, the addition of the microalgae did not significantly affect the levels of total saturated and total monounsaturated fatty acids in the diets compared to the control. However, the highest inclusion level of Serokiniana in the CS30 diet resulted in decreased levels of palmitoleic acid and oleic acid. Similarly, increasing Chlorella vulgaris inclusion also resulted in decreasing amounts of oleic acid in the diets.
1 minute left.
Okay. Only the commercial Serokiniana significantly increased the levels of linoleic acid and total omega-6 fatty acids in the diet, while the CV100 diet had the lowest arachidonic acid among all of them. And just to skip a bit because the time is running, the most important thing is that neither of the species, the microalgae species, significantly affected the EPA and DHA of the diets. And now regarding the fillet, it was significantly affected to a certain extent by the addition of the microalgae. Some changes in the individual saturated fatty acids, although it didn't result in any differences in the total saturated fatty acids. In monounsaturated fatty acids, a decreased level of total monounsaturates was observed in the 700 group compared to the control, mainly due to the decreased levels of oleic acid. While the gradually increasing dietary inclusion of vulgaris also significantly reduced the levels of linoleic acid and total omega-6 bufas in Seabrooms mussel. Meanwhile, the exact opposite occurred in the commercial Sorokiniana fed fish, which had the highest levels of these fatty acids. Now for the omega-3s, none of the tested microalgae in any inclusion levels significantly affected the EPA and DHA levels in the fish, which means that the fish meal replacement by this microalgae did not reduce the essential for both fish nutrition and human health fatty acids. However, vulgaris in the highest inclusion resulted in increased levels in some omega-3s, such as alpha-linolenic and linoleic acid. And so to conclude, the inclusion of either Chlorella sorokiniana or Chlorella vulgaris in the diet, substituting up to 30% of the fish meal protein, did not adversely affect the survival and voluntary feed intake of the fish, nor did it compromise the growth performance and feed efficiency in gillhead sea bream. This indicates that these species at the inclusion levels tested were well accepted by sea bream. It's also worth mentioning that the inclusion of commercially Sorokiniana, resulted in higher voluntary feed intake, which demonstrates its high palatability. However, when Chlorella vulgaris was used at the highest inclusion level, it resulted in decreased voluntary feed intake and increased daily feeding rate, which means that maybe it was deficient in some nutrients. It is widely accepted that fish might consume a nutritionally deficient diet at a higher rate in order to satisfy their nutritional requirements. The lipid content of both Chlorella sorokiniana and vulgaris is characterized by high levels of linoleic acid and alpha-linolenic acid, but contains very few amounts of EPA and DHA, and thus substitution of the fish meal might pose a risk in reducing those essential fatty acids in the fish muscle. Our results showed that this did not happen, and that dietary substitution of fish meal, either from the pilot-produced biomass of Chlorella sorokiniana or from commercially available biomasses of Chlorella sorokiniana and Chlorella vulgaris, does not reduce the EPA and DHA, and therefore does not diminish the fillet's nutritional value for the consumer. This research has been funded by European Union and Greek national funds. I would like to thank you for your attention, and I am open to any questions you might have.
Thank you, Ms. Galogianni, for the excellent presentation. Now we have 5 minutes for questions.
Thank you, Ms. Galogianni, for the presentation. It is always very interesting to see presentations on alternative raw materials for feed ingredients. I saw that the 30% is the one that it's better, a better option. Do you believe that it's feasible to have a mass production of chlorella for the feed industry to replace at least 30% of fish meal, or need to have a, how to say, significant amount of money for investments on land facilities on land to produce that amount? I'm not sure if you are, this is more financial question, but when we're trying to find an alternative, it's not only that the significant reduction of fish meal, but if it is feasible as to proceed to this option. Thank you.
Yes, you are quite right. Chlorella has been mass produced for some time now. Although it still is not economically feasible to replace fish meal or even have it included in the diet at such high inclusion levels. There has to be a scale up, and in order for the production to be more economically sustainable.
All right, thank you. So it's a good option, but not for now. It's something that to start thinking about on our way to reduce the fish meal and to find alternative ingredients.
Yes, it's a good option, but at a lower inclusion levels, I think, at the moment.
Okay, thank you, Ms. Galogianni. Do we have any more questions? So at this point, our session is ended. Thank you all for your participation.
Hello, I would like to inform you that the session will be starting in 3 minutes.
Απλά εγώ θεωρώ πολύ παράδειγμα ότι η γυναίκα που έχει τέτοιο κοιτά ζωή του.
Good afternoon. Can you please turn your microphone off and so that we can start the next session in inland aquatic ecology and resource, processing of aquatic products. And we will start by the talk of the paper of Koutalakis, Giatas, and Saimes, presented by Giatas. Multi-criteria decision analysis for mapping erosion potential in the Agitis River watershed in northern Greece. So, is Mr. Giatas going to present? Please, 10 minutes for the session.
Good morning.
Welcome, Mr. Giatas. Can you turn on your microphone?
My microphone is on. You can see my presentation?
Yes. Can you share in full screen, please? Thank you.
Good morning, everyone. My name is George Giatas, and I will present you the multi-criteria decision analysis for mapping erosion potential in the Agitis River watershed in northern Greece that we prepared with my colleagues Paschalis Koutalakis and George James. At first, we will have a small introduction. We will talk about the material and methods, the results, and discussion and conclusion. Soil erosion is a gradual process that occurs when the impact of water or wind detaches and removes soil particles, causing the soil deteriorate. The accelerated soil erosion is one of the most widespread environmental problems worldwide. The Mediterranean region is a vulnerable hotspot of land degradation, soil erosion, and desertification. The assessing of vulnerability to soil erosion is crucial for improved sustainable land use planning and management. There are various methods for soil erosion modeling in geographic information system. The multi-criteria decision analysis, known as MCDA, uses multiple criteria and parameters as inputs for better decision-making processes. A GIS-based MCDA approach can transform and combine geographical data, and with this one, we can value the judgment to solve spatial problems. The analytical hierarchy process is the most commonly used and effective method to incorporate all this in the MCDA process. The AHP has been utilized in many previous studies to weight either the flood-related or the erosion-related factors. The specific object of this study is to identify and map the areas prone to soil erosion in the Ichthyology River basin in the northern Greece. The study area. The Ichthyology River basin is a source from the Ichthyology cave known as Mara, which is located in the Phalacro mountain. It covers an area of 2,077 square kilometers and covers the region units of Drama, Ceres, and Kavala. The river drains in the Strimonas River and then in the Aegean Sea. The main plain of the area is characterized by agricultural land with residential areas. At the higher elevations, where we have steeper slopes, we can find sclerophyllous vegetation, forests, pastures, and spiral shrub vegetated areas. It has huge hydrological and hydrogeological potential and soil erosion problems and torrential flood phenomena. Here you can see in the left-hand picture, you can see the area that covered the Ichthyology Basin River. And in the right one, you can see a section of the Ichthyology River. For the MCDA, we used 11 erosion controlling factors that computed, mapped, weight, and overlaid all together. So we will be able to identify and map the potential erosion-prone areas in the district. This criteria was the elevation, slope, flow accumulation, stream power index, rainfall, drainage density, the topographic wetness index, the land use and land cover, the NDVI, which is the normalized difference vegetation index, the soil type, and the curvature. For the MCDA, we use the analytical hierarchy process known as AHP that was adopted in the current research in order to correspond to erosion-related factors. The criteria weights based on the local physical characteristics and the assessment of previous studies. It has values from 1 to 9 that was assigned to each factor to construct the pairwise comparison matrix. 1 refers to equal importance and 9 refers to extreme importance. The normalized pairwise comparison matrix table was prepared by dividing each value in the column by the sum of the column of the matrix. The weight of each factor was computed by dividing the sum of each row in the normalized pairwise comparison matrix table by the number of the factors. And the consistency ratio was calculated to assess whether the comparison is correct or not. If the CR is below 0.2, it means that the pairwise comparison matrix has an acceptable consistency. Otherwise, if the CR is greater or equal to 0.2, it means that the pairwise comparison has inadequate consistency and the comparison process must be repeated until the value of the CR is below 0.2. Here you can see the pre-wise comparison matrix table on the upper left corner. Then you can see the normalized pairwise comparison matrix. And on the right, you can see the calculating consistency of our work. The multi-criteria decision analysis, for the multi-criteria decision analysis, in each erosion-related factor was reclassified to a common measurement scale from 1 to 5 with the use of the ArcGIS software. Then the factors weighted using the equation according to the HP approach, and the spatial layers were integrated and overlaid all together in the spatial analyst extension of the ArcGIS 10.4 environment. Here you can see the reclassification of the 11 erosion factors to a common measurement. 1 is very low, 5 is very high. In the first one, you can see the digital elevation model, the slope, and the curvature. Here you can see the flow accumulation, the stream power index, and the drainage density, the rainfall, the topographic wetness index, and the NDVI. Also, we have land cover and soil. After we combine all these layers, we produced this map. And as you can see with the blue color, each area is represented very low erosion and cover an area approximate of 5,050.8 square kilometers. And with the red, you can see the areas with a very high erosion rate and cover an area of 2,076.9 square kilometers. The land use layer showed that more than the half of the study is located in flat agricultural plain and characterized by low and very low susceptibility. The remaining area of the watershed experienced moderate, high, or very high susceptibility to soil erosion. The high and very high susceptibility of soil erosion was found in areas with high elevation, drainage density, rainfall amount, flow accumulation, and in vulnerable soils and bare land of spare vegetation. The verification of this of the MCDA was done based on the bank erosion hazard index, which has already utilized in different locations of the stream network by field visit and cross sections. As the Ichthyology basin had diverse land cover, various best management solutions are proposed. That was done based on a short bibliography review on the specific subject. Also, we developed an online decision support system to select the proper nature-based solution based on our study area, characteristics, and requirements. If you want to access the online DSS support system, you can use the QR code on your left. That was a program that financed by the European Union in the framework of the Joint Operational Program Black Sea Basin 2014-2022. For more information, you can visit our website and our social media. Thank you for your attention.
Thank you very much, Mr. Giattas. Το λέω σωστά?
Yes.
That's okay. Are there any questions from the audience? No? Can I ask one?
Of course.
Okay. Do you think that you can combine all these findings of geomorphology and erosion in this area with biological indicators? I mean, with fish or invertebrates or vertebrates living in the area to see if trace metals or substitutes from erosions can provoke some indexes in the biology field?
I think that if we prepare correctly the needed outputs, it could be possible to add all these layers.
Thank you very much. Please stop sharing your screen. Okay. Sorry. And okay. Ανέχει. And the next speaker, the next presentation is structure of benthic macroinvertebrate communities of selected watercourses within target area in Bor district. Is there a presenter for this presentation? Here on the paper, it should be presented by Mr. or Mrs. I don't know, Antjus, Zoritz et al. Επόμενο. Is the representative for the paper? Okay, we can move on to the next one by Elias et al, presented by Stamataki. Crowd water sampling and photographic data analysis, application to the Evergetulas River here in Lesbos, in Mytilene. Mrs. Stamataki, welcome. You have approximately 10 minutes for the presentation. You can turn your microphone on.
Yes, hello.
Hello.
Let me fix everything.
Okay.
Sir, can you see my screen?
Yes, you can do it on the full screen.
Let me see, because I have to change that. Give me a second. Is it full screen now?
No, not yet.
Why?
Probably you have to stop sharing and start sharing again from full screen.
Yeah.
Αυτό δεν είπαμε. Share your screen, not the PPT.
Okay. I think this should do the work.
Yes, it's okay.
Can you see it now? Nice. Okay.
Yeah. We can do it from the beginning. Okay.
Yeah. I think we are ready. So, good morning, everyone. Thank you for being here today. My name is Maria Dana Stamataki, and I'm pleased to present this research on behalf of my colleagues, Mr. Elias, Mr. Siarkos, and Professor Orania Zoraki. In this, you want me to move this here? It's better. In this presentation, we will discuss how we utilize the crowd water application software to monitor and analyze the flow conditions on the Evergetulas River in Lesbos, Greece. So, our study aims to explore the effectiveness of the citizen science in environmental monitoring, specifically focusing on the seasonal variations of river flow conditions. Let's take a look at our flowchart. We study the Evergetulas River. That was our case study area. We used the crowdwater software to conduct the photo sampling. We did the photo sampling analysis in 18 points in the Evergetulas River. We, of course, produced mapping material and we cataloged everything that we found, and the results were the observation analysis and the importance of groundwater and citizen science in general. Now, to our case study area. The Evergetulas River is located on Lesbos Island. It is the largest river basin of Lesbos. It flows from Mount Olympus to the Gulf of Viera, as you can see on the map. And it has a diverse ecosystem, and it is known for its immense biodiversity. This river is particularly interesting due to its intermittent flow, which varies from seasonal changes. As you can see in the map on your right, we have the points of photo sampling. We have 18 points of observation that we took the data from in total, and we also have the table with the names of each of the locations that we used the data from. So let's talk a bit about groundwater. Groundwater is a project that was started in April 2016 from the University of Zurich. This project was created to give people that are not researchers or scientists let's say, the usage of a simple application to engage into rivers as researchers. This is a pioneering citizen application. It aims to engage the citizens as researchers, and it is very fundamental to us because it collects hydrological data very easily. Users have the option to initiate observations just by taking a photograph of their specific site location of a river. As you can see on the video on your left, you can zoom in to your specific area that you like, and you can update or create a new pinpoint with your observation just by taking a photo and categorize it by your eyes. It's very easy for everyone. So, during our data processing, the collected photos were categorized and analyzed to create mapping material and the catalog of our data. This process involved classifying the flow conditions based on the groundwater system classification and visualizing the data to observe the seasonal variations of the river's flow. We will start as an example from site number 4. We classified the conditions from February 2023 until July 2023. We saw that in this site we took 18 samples also. Don't confuse yourself. We had 18 points with 18 samples. And we saw that in March and in June we had the most extreme variations on the river's flow. Here, you can actually see the photos that we took. In your left, March, we had a continuous flow in this part of the river, but in June, we see something not quite the same as in March. We had a dry condition happening in this river part. Also, we did the same process in site number 10. It was like on a more mountainous area. In this site, we had a continuous flow during all of the months, as you can see on this diagram also. And we took the similar pictures. As you can see, in March, we had water. And from the same point of view, we had also running water in June. So we didn't have any variations in this flow. So let's examine how the main conditions of the Evergetulas River were during March and June. We selected specifically March and June because we had the most extreme, let's say, variations in river flow. In March, on your left, all of the sampling sites were indicated by blue dots, which means we had running water, as you can see in the legend before you. This suggests that during March, the river was in a flowing state across all of its sections. But we have a different, let's say, state during June. We have a significant change, particularly in the downstream sections, if you can see number 1 to number 4, and in the upstream sections, number 15 and 14. Indicated with orange and yellow circles, as you can see, which stand for running water, standing water or dry stream bed. So we use maps to effectively illustrate this dynamic nature of this river and the spatial trends of the flow. In our conclusions, so our study demonstrates the significant contribution of citizen science in hydrology. The data collected revealed how various sections of the Evergetulas River, in our case, respond to seasonal changes and rainfall. This approach not only validates the reliability of crowdsourced data, but also emphasizes the importance of public participation in the scientific research. Simple photographic observations that we used to create this study provide valuable insights into river flow patterns, making it easier for us and to non-specialists especially to contribute meaningful data without the need of complex equipment. We just used our phone. So understanding all these patterns is very crucial, of course, because we need them for effective water management and conservation efforts. For some future steps. So our study has outlined 2 main future steps to further our understanding of the Evergetulas River. First of all, we plan to develop comprehensive models for river flow. These models will help us gain a long-term understanding of the river's response to various environmental factors. This is very crucial for developing strategies, as we said, to ensure sustainable management for water resources mainly. Another key area is to investigate relationships between flow intermittence and climate indexes, like the SPEI or Standardized Precipitation Evapotranspiration Index. These relationships will involve, let's say, metrics like number of zero flow days and stuff like that. So these future steps will build our current findings and contribute to a more detailed and predictive understanding of the Evergetulas River. So this is our reference, if anyone wants to see them. And I would like to thank you here, my colleagues and the University of the Aegean for their support. And especially thanks to Save Our Water Erasmus Plus project that is funding this presentation. So thank you all for your attention, and I'm happy to answer any questions you may have.
Can I ask a question?
Yes, of course.
Hello, Mary. Out of curiosity, so these images are taken by people themselves, right?
Yes, by this application.
Have you thought also to apply wildlife cameras and train them? Actually, you can with machine learning and all the imagery you already have, you could actually train this approach whereby you don't need people anymore to go to these places. Wildlife cameras are put on several places. Because you have trained it with machine learning, it will recognize the status of a river. Have you thought about that?
Yes, that's actually a very good question, because it will be very helpful for us, for scientists, to just put, some equipment and just see whatever is happening in the river, but it's actually very expensive. By having crowdsource applications, not only crowd water in our case, but in general, because there are many, it makes it easier, and you can actually see many parts of the river, not only one. Because if you put equipment like that, you have to put it on a specific place. And with this application, you can actually go in the full extent of your area that you want to see anything. In our case, it's a river, so most of its parts are accessible easily. So if a researcher or someone that likes nature in general wants to go and just take a picture, it actually helps a lot to see what's happening in most parts of the river.
Yeah. So my suggestion was more in the sense that the number of occurrences of a measure point would be much more regular, because I saw in your graph you have a slope at a certain point where the water dries up in the river, where with fixed wildlife cameras you would actually have quite detailed, regular such measure points. In any case, I read an article about that a couple of weeks ago. That's actually why I brought it up. I will check if I can find it. We'll send you back, because I remember in that article they used two specific machine learning approaches. I think it's open source. And given the fact that you have all these images, actually you can apply it because you can self-learn the system and better understand. So I will send it to you.
Thank you. Thank you. Yeah,
okay.
Of course.
Thank you very much for your nice presentation.
Thank you.
Can we have also your name?
It's
No,
Stamataki
Mrs.
Maria.
Stamataki, the one who is asking the questions for the audience to know. Can you turn your microphone on, please?
Συγγνώμη, είμαι Karol Vanizak από Βέλγιο.
Okay, thank you very much.
Ευχαριστώ.
So, thank you very much, Mrs. Stamataki, and we can move on to the following presentation by Mr. Lukoyanakis et al. The presentation is microbiological changes and self-life of smoked mussels meat during storage at 4 degrees Celsius. Mr. Lukoyanakis. Εσείς είστε? Είστε εδώ. Okay.
Okay, so thank you everyone for being here. Today, my name is Manolis Lukoyanakis. Today, I will be presenting to you my bachelor's thesis with the subject of microbiological changes and shelf-life of smoked mussels meat during storage at 4 degrees Celsius. As it is well understood, products, especially of the food industry, can have their characteristics negatively altered through a number of factors, such as chemical ones and physical ones. But by far, the most important out of all these factors is microbial activity, especially when regarding fresh finfish and shellfish. If we dig in a little deeper in the subject of what specifically causes the most damage in the realm of the microbial activity, we find the specific spoilage organisms, or SSOs, which essentially are a consortium of bacteria that in certain conditions dominate over all others and can produce metabolites responsible for several unpleasant odors, and off flavors, eventually leading to the sensory rejection of the product. Here we have a diagram explaining all that a bit more detailed. As you can see, the blue line, once the blue line representing the SSOs, or again specific spoilage organisms, begins to increase rapidly and reaches a high enough threshold, This is the same time we see a sudden increase in the pink line representing the metabolites, thus producing, once again, the unpleasant off odors and off flavors, and resulting in the end of the shelf life of the product, represented here by the straight black line. Okay, so what can we do to combat these troublesome SSOs? The best way to combat them is using a technology called the combination health theory, which essentially tells us that instead of combating the SSOs through a single countermeasure at a time, for example, high temperature, different pH levels, and so on and so forth, we use a lot of different of these attack methods all together and attack them at the same time, like we do with liquid smokes. For example, we can use, you can see here, food preservatives, high temperatures, different pH levels, water activity, harmful bacteria. The SSOs can't handle all that. Okay, so what was the aim of this work? The aim of this work was to monitor microbiological and sensory changes of muscle meat filled with tap water and liquid smokes in order to prevent rapid bacterial growth and retard spoilage. The mussels, Mytilus galloprovicinalis, were collected from a Greek farm at Halastra, Thessaloniki region. The flesh meat was removed from the cells and was packaged in plastic pouches containing 150 milliliters of water each. This is the most important step. Two different liquid smokes, Rudy Smoke L9 and Rudy Smoke G6, were used in a concentration of 2% each and were added in the plastic pouches in two different treatments. And of course, the packaged mussels were stored at 4 degrees Celsius. The nutrition broths used in this microbiological analysis were TSA, CFC, iron agar, MRS, and VRBGA or VR. And every time we went to take a sensory measurement, we would use a scale from 1 to 5, with 1 being spoiled, 5 being excellent, and 3 being the minimum acceptability level, meaning anything below 3 was deemed as sensory rejected. What did the results show? As for the control samples, meaning the samples untreated with any kind of liquid smoke, the results showed a shelf life of around 8 days, with a shelf life determinant, meaning the thing that caused us to reject it sensorially, was unpleasant odor. As for the samples in both treated with both liquid smokes, both liquid smoke L9 and G6, and in both treatments with tap water which are sterilized and non-sterilized, the results showed a shelf life of 10 days, with the shelf life determinants, in this case being both an unpleasant odor and an unsightly dull appearance. Meaning, of course, that mussels treated with both liquid smokes exhibited an extended shelf life of around 2 to 3 days more than compared to the control subject. Here we have 3 diagrams explaining again of that in a bit more detail. The first being the control, then the mussels treated with G6 smoke, and then L9 smoke. As you can see, just by glancing over these 3 diagrams and comparing the first 2 to the other 2 containing liquid smoke, you can see that the last 2, not only the number of the total bacteria is a lot lower than the control sample, but the growth rate of the bacteria is also decreased. Meaning, of course, that in both cases, both smokes inhibited microbial growth and extended mussel shelf life. Thank you for your attention. If you have any questions, feel free to ask.
Thank you very much, Mr. Lukoyanakis. Are there any questions from the audience? No, can I ask some?
Yeah, of course.
Why do you store the mussels at 4 degrees Celsius?
We stored them at 4 degrees Celsius specifically because we deemed that this was the ideal temperature, the preferred temperature for the mussels.
Okay, and the common temperature
yes,
for
the common temperature
food
of the mussels stored
in general.
Generally.
So the days with the smoke increased by 2 or 3 days? compared to the control?
Yes,
Okay.
both smokes, both G6 and L9 smoke.
Okay. Does it have to do with the smoke that it has some biological properties?
Of course, yes. One of the reasons for the extended shelf life was that generally all smokes, liquid smokes, are shown to have, used in the food industry, I should say specifically, have proven to have antimicrobial activity.
Properties. Okay, so it's a result you have expected.
Generally,
in a
yes.
sense.
Generally,
okay,
yes.
okay. Thank you very much.
Thank you.
Thank you. So we will call again to the audience the second presentation, if they are present, the structure of benthic microinvertebrate communities of selected water courses within target area in the Board District by Zoric et al. Is there anyone to present this paper? No. So we can finish our course here, our session. Thank you very much for being here and have a great afternoon.
Greetings, everyone. I'd like to welcome everyone to this session. The title of this session is Field Environmental and Management Education. I will be the chair of this session. I'm Spiros Spondylidis. Now, the duration of this session will be 1 hour approximately, from 1 o'clock until 2 o'clock. We'll have 4 oral presentations in a hybrid form, so we can have oral presentations here in person with remote attendees. 4 presentations, yes, and the rules are that each presentation will be approximately a duration of 15 minutes. 10 will be the oral presentation, another 5 will have for questions. I'd like everyone to keep those times. I'll keep a timer. I'll issue a warning at approximately 9 o'clock. And okay, these are the rules. We can begin our presentations. The first one is by Mr. Ioannou, Mr. or Mrs. Ioannou, Mrs. Ioannou, okay, with the title Study and Best Practices to Reduce the Environmental Impact of the Fishing Vessels in Cyprus.
So hello, my name is Konstantina, and I'm a research scientist at the Cyprus Marine and Maritime Institute. So to start with, although it is important to decarbonize long-distance shipping, it is equally important to decarbonize short sea routes, which involves about 30% of the global greenhouse gas emissions and about 1.2% of the global fuel oil consumption. Therefore, Fishing Green is a project that aims to propose the best practices that are applicable to the Cypriot fishing fleet in order to reduce their fuel consumption and their respective emissions. So surveys were carried out to the fishermen in Cyprus to obtain information about the technical characteristics of the engine and the operational profile of vessels. And the analysis of the measurements was obtained from 10 Cypriot fishing boats, 6 with a multi-purpose license and 4 with type A license. This is the measurements methodology. So Lancome 4 is a mobile gas analyzer and was used for the emissions monitoring in real time to be able to correlate the emissions profile with the operational profile of the vessel. And note that the analyzer could not be used in situations where the exhaust gases were mixed with seawater because this would have damaged the equipment. The HIC Micro M30 thermography camera can be used to detect any heat losses in the engine room. So thermal loss of energy implies additional fuel consumption since temperature is an indicator of the normal operating conditions of an engine. So pictures were taken during the warm-up phase of the engine and when the vessel was at cruising to ensure that the measurements were taken when the engine was at steady state conditions. The VA5 Pro vibration analyzer can be used to record vibrations that may arise due to imbalance or misalignment, wear or faults in the bearings of the engine, or any mechanical looseness. And at last, the Lamtech waterproof camera was used to take pictures and videos of the wetted surfaces, such as the hull, the propeller, and the shaft, to examine if organisms have grown on their surface and into what extent. In the next few slides, I will show you the results from the measurements, and note that most of the examined vessels were over 20 years old. So the visual inspection of the engine rooms was an initial assessment of the condition of the engine room and the level of maintenance. As you can see, the blades and the belt need replacement due to extensive rust buildup. Also, in many fishing boats, the pipes were corroded and the engine block was covered in fuel streaks. The thermal imaging of the engine and the exhaust also revealed that in 6 boats, the exhaust was not properly insulated, and in 4 boats, the temperature between the cylinders was not uniform. This could be due to the insufficient maintenance of the engine, which therefore reduces the quality of mixing during combustion and hence reduces the efficiency of the engine. So in the underwater inspection of the wetted surfaces, as you can see, there were areas with extensive fouling and cavitation. Also in areas where there is a strong change in the geometry of the hull. So between the stabilizer fin and the hull, a greater growth of aquatic organisms was observed. And also rust was observed in the propeller and the rudders. That could be due to the lack of anodes, or in this case, due to the incorrect placement or maintenance of the anodes. The anodes are not to be painted or greased, as observed in some fishing vessels. This type of corrosion is an electrochemical process. Therefore, the users should be informed and trained for their correct application to prevent such types of erosion. And also the boats with a multi-purpose license were expected to have a greater growth of organisms on their hull due to the larger wetted surface area. However, this was not the case, and this could be due to the more frequent cleaning of the hull or the use of better quality hull coatings. The fishermen also indicated that the fishing season lasted for 7 months. Therefore, hull was expected to be maintained at least once per year. However, this was not the case for all the examined boats. As you can see in the left shot, shows the presence of extensive fouling, and this is because of the hull being maintained 26 months ago, which in turn was the longest non-maintenance period. In both the middle and the right shot, illustrate a reduced growth of organisms and cavitation. However, as you can see, net ropes were still attached to the propeller and the shaft area. The ISO standard was used to benchmark the results we obtained from the vibrations analysis of the engine. And overall, the results were considered satisfactory, indicating that there was not any imbalance or misalignment in the propulsion system or any sort of looseness in the mechanical parts of the engine. The emissions measurement can indicate the condition of an engine and by extension its fuel consumption. Emissions were observed at low engine speeds, so below 800 RPM with, I don't know if you can see clearly, but the light grades, the sulfur dioxide pollutants, and they were not presented at all at higher revolutions. The sulfur dioxide pollutants were observed in idling conditions, and this could be due to the type of fuel used. Some fishermen indicated that they used agriculture fuel, or from issues arising from the lubrication system or the turbocharger. Again, the fishermen gave estimates about their overall fuel consumption in a day for a single trip. A fuel meter to estimate the fuel consumption was not used because this would have been intrusive to the engine. So therefore, we estimated the fuel consumption using the emissions measurements. And as you can see, the values for the vessels at cruising are quite high. And this could be due to the age, the rating of the engine. So most of the engines were 20 years old and above. and or the level and frequency of maintenance. So in the last section, I will present you the simple and advanced measures applicable to the Cypriot fishing fleet to reduce their fuel consumption. So for the hull, it is important that maintenance is carried out. The maintenance should be carried out before the start of the fishing season. Any foreign material should be removed. And the maintenance and the geometry change points is also important due to the greater growth of organisms. The engine, once again, must be maintained periodically. Any worn parts or machinery within the engine room that is covered in rust should be replaced. And also the maintenance of the auxiliary systems is important, since some fishing boats had photovoltaics and they were also covered in dust. And slow steaming, so reducing the vessel speed combined with changing the propeller characteristics, can also help to reduce the fuel consumption. For the advanced measures, we propose to use energy efficiency monitoring devices. An example includes ZEST, which is an electric vessel with an integration of an innovative power energy management and monitoring system, which involves the creation of its digital twin to be able to estimate and monitor the energy consumption required for propulsion and power generation. In general, improved propulsion systems such as electric vessels, diesel electric or solar powered, to mention a few, and the transition of mechanical hydraulic control systems to electronic ones is also advised. Also, the use of modern cooling systems with energy consumption management. Now, the use of oceanographic data along with route optimization systems is very important, since fishermen indicated that they had to travel longer distances to search for better fishing grounds. And despite that greater distances increase the fuel consumption, the climatic characteristics also change per region. Therefore, this causes the engine to have to constantly adjust to the changing conditions. And at last, we propose to the fishermen to use different mesh sizes, types of knots, and panel cuttings. Thank you for your attention.
Thank you, Ms. Ioannou. Is there any question from the audience?
Yes.
Mr. Valagrakis, yes.
But do you hear me?
Yes.
Yeah? Okay, just a question. Have you done any cost-benefit analysis to see how much all these changes and these upgrades will cost compared with the kind of benefit fishermen will have?
What type of analysis?
Cost-benefit analysis. Money. How much it's going to cost to implement all these changes and upgrades, and how which going to be the profit or the benefit for the people?
We didn't conduct in terms of economic assessment yet, but of course the solutions we proposed in the advanced solutions will cost money. But even the hull maintenance was costly for the fishermen, because in Cyprus they make them pay money to take out the hulls, and according to the stay of the boat outside, they are charged accordingly. And as I already mentioned, they even used agriculture fuel that was cheaper. So yes, of course, first we suggested the simple measures for this reason, that I think all the fishermen should apply the maintenance required on their hull and in their engine rooms as a start, and then of course apply the advanced measures too.
So basically, there is no incentive for them to do any of this.
No, there are no currently incentives in Cyprus, and this was a problem also mentioned in the surveys we carried out.
Okay, thank you.
Thank you.
I would also like to ask a question. Regarding your advanced measures, you talked about route optimization options. I don't know what's the current status of this kind of services in Cyprus, and that's what I would like to ask. Is there any fishery advisory service that can be utilized that it's handled by Ministry of Agriculture and Fisheries in Cyprus? Are you aware of something like that?
Not currently for the fishing. But most research centers are looking more into route optimization and then try to apply it in the fishing.
With proxies to identify potential fishing zones, I imagine it's what we're talking about, with utilizing remote sensing data like chlorophyll, temperature to specify the profile of the target species.
Yes, and also the simulation of the sea state.
Okay.
Yeah.
Thank you. Thank you very much.
You.
Thank you. Thank you, Ms. Joanna. We can move on to the next presentation by Mr. Stamatis. The title of the oral presentation is A Comparison of Airborne LiDAR with Ground-Based Methods for Coastline Extraction.
Εντάξει, ακούγουμε. Ωραία. Good evening. My name is Stamatis Panagiotis. I'm a PhD student candidate at the University of the Aegean in the Department of Marine Sciences and a member of the Marine Remote Sensing Group. I will be presenting a part of my PhD research, specifically the comparison of coastline extraction using an airborne LiDAR system with ground-based methods. The environmental management of the coastal zone requires rapid, accurate, and up-to-date information. Accurate coastline extraction is crucial for wire applications, including environmental monitoring, coastal management, and mapping. It helps in understanding and managing coastal erosion, habitat preservation, and land use planning. Effective coastline management ensures the protection of coastal ecosystems, reduces the risk associated with the coastal hazards, and supports the sustainable development in coastal regions. In this video, we see the airborne LiDAR system in flight for data collection, and I will provide some more detail shortly. The study area that was used is Petra Beach, located in the northwestern part of the island here on Lesbos in Greece. So, for data collection, the Topcon Hyper-VR GNSS receiver was used. This instrument had a dual purpose. It captures the ground-based shoreline and provides the point data needed for georeferencing the LiDAR data. The next video shows a brief corporate presentation of the LiDAR, demonstrating its usage and the result it provides. The airborne LiDAR system used is the YellowScan VX15. Some important specifications of the VX15 include a weight of 2.6 kilograms, including the battery, a range of up to 100 meters, an accuracy of 5 meters, and precision precision of 1 centimeter. So accuracy is the 5 centimeter. The UAV chosen is the DJI M600 Pro, selected for its capability to carry heavy payloads, such as the LiDAR system that we use on this study. The field operation includes the field checks, that is the check of our area of interest, the takeoff landing area, pre-flight checks that we ensure that the LiDAR is mounted correctly to the UAV that we are using, protective cap are removed, battery charger is charged and correctly inserted in the LiDAR, and the USB drive is connected. Also, we have the base station setup. That is the first thing that we do on the field, and the recording time is at least 1 hour. Last is the IMU initialization. That, as you can see here on this diagram, it is for the IMU initialization. Sorry, we have 3 just straight lines back and forth, and 180 degrees turn. So the methodology consists of LiDAR data collection and point data collection with GNSS, pre-processing that includes visualization and georeferencing, and processing where digital elevation model are generated, and coastline is extracted using elevation contours, and the shorelines are compared using the digital shore analysis system tool. For the result, here on the left, you can see the orthophoto map generated from the photos collected during the LiDAR flight. On the right is the 3D point cloud results from the LiDAR. The color scale corresponds to different ground elevations. As you can see near the sea is the blue color, and as we can go higher, as rooftops or trees, is going to the red color, orange and red color. Next, here on the right side, you can see the points generated with a rover receiver of the HyperVR, which eventually formed the GNSS coastline. Here. In the middle, we observe the generated digital elevation model extracted from the LiDAR data. The separation between land, the dark colors, here, and the sea, the bright colors, is clearly visible. Additionally, elevation contours are depicted in green with 0 elevation contour representing the LiDAR coastline. The map provided illustrates the 2 coastlines along with the transect and baseline created by the DSAS tool for measuring distances between them. With the yellow color is the GNSS coastline, with the orange color is the LiDAR coastline, and here is the baseline from the DSAS tool and all the transect along the coastlines that are generated, and the different colors represent different distances along the coastlines. A total of 32 transects were generated along the coastlines, with the average distance measured at 3.6 meters. The maximum reaching 4.3 meters and the minimum at 2.9 meters. The graph here shows the measured distances across the transects. This is the 32 transects here and the distances. In conclusion, the shoreline generated by LiDAR does not coincide with the instantaneous shoreline measured by GNSS, but is accurately represent the high water level defined as the upper limit reached by water. Airborne LiDAR surpasses terrestrial methods in terms of efficiency, accessibility, cost effectiveness, and the provide of 3D data. Finally, this research represents a small part of my broader work for my PhD, in which I use airborne LiDAR to study coastal erosion. Thank you for your attention.
Thank you, Mr. Stamatis. Is there any question from the audience? You have a question?
Yes. It's not my discipline. I'm for other discipline, but I saw the last years a lot of discussion about LiDAR, documentaries in TV about the use of the tool and the results and how not complex this method is. From your experience until now, do you think that it will be a useful tool and it can give us results that are comparative with old style typical method on the field?
Are you asking for my research for coastal erosion or generally for any other research that it can be done with a LiDAR?
In general, in our sciences, in coastal and ocean sciences, and more specific on on the erosion problem.
So at this moment, I'm exactly at this phase for my on my PhD. I have the equipment, the LiDAR, the UAV, and I'm trying to see what I can do with this equipment, what results I can have, and how useful it will be. At this moment, I can answer to you that yes, the LiDAR technology it's efficient, it's state-of-the-art technology, and it can provide us with data that we can use it on our research field. I can't say more because I'm right now at this process. Yes.
Is there any other? We have another question from Professor Velegrakis.
Yes, hello. Just something I didn't understand very well. It is, you have the GNSS survey, and apparently what you do is walk on the coastline with the RTK GPS. How do you define the coastline?
Yes, exactly. I had the Topcom receiver, and I personally walked on the water line at the end of the water at this right time there on the beach, and I measured the points, and eventually I just from the RGS extract a line on these points. Yes, I just walked on the beach on the.
And when did you take the LiDAR? The same time or sometime later or another day?
It was just the same day. First, I took this data of the GNSS receiver data, coastline, and then I did all the fly mission for the LiDAR.
Yeah, just an observation. If you want to have this erosion studied, you have to have some time series of that, very close, because of course, the LiDAR maps you the wave run up, and when you walk, you measure something different. So basically, by definition, they're not going to coincide, and the accuracy is going to be reduced. Maybe you need to have some repeated service the same day to be able to get some better idea how the coastline behaves that particular day. And I would propose that you need as well to have some kind of water level study. For example, some kind of equipment to measure the water level, so to have an additional control in your experiment. Thank you.
Okay, thank you for this, and just to tell you that the idea of my PhD is exactly that. I will have a time series of data, of course, of the same study area to coastal erosion. Yeah, and also we will add the data.
The same day, if possible,
okay.
as well. Not only a time series of longer having this kind of surveys in different kind of, but the same day as you are there, you have to have several of those. Thank you.
We have another question from Professor Topouzelis.
Okay, thank you. I just want to follow up the question from Professor Velegrakis. So once you went there and you did the GNSS mapping, you did it on the wave run up with the GNSS, or you did it on exactly the place where the water was stopping on the beach, because that's very crucial in order to compare the two data sets.
For the GNSS data, I was working just on the where the water is just ending on the right time.
Okay, so following my question now, if you have been taking the data on the wave run up with GNSS, would you have expected more precise accuracies from the comparison?
Of course. Probably the two coastlines will be together, and the distance will be very short on the DSAS analysis tool. But it was on purpose to walk on this line because I wanted to map this coastline that the water was ended.
Okay. Thank you.
Okay, thank you. Thank you, Mr. Stamatis. We'll move on with our next presentation for this session by Mrs. Papageorgiou. And the title of the work is Estimation of Chlorophyll A using Multispectral UAS Imagery.
Thank you, everybody. My name is Nicoleta Papageorgiou, and I'm an undergraduate student here at the University of the Aegean at the Department of Marine Biosciences. This is part of my undergraduate thesis, the paper that I did, that I'm going to be presenting you today. So this study proposes a method for estimation of chlorophyll A concentration in the marine environment using multispectral imagery from unmanned aerial systems, otherwise known as UAS. We did this through the development and testing of a specific algorithm that aims to accurately determine the chlorophyll A concentration using only multispectral imagery. 7 different indices in this case were used and evaluated to test their effectiveness in estimating chlorophyll A with statistical correlation used to identify the most accurate indicator compared to field measurements. Our approach also aims to estimate chlorophyll A by eliminating the need of extensive in situ data collection. Specifically, this study takes place in the Gulf of Yera here in Lesbos, Greece, where in situ samples and UAS images were taken of the area consisting of 6 buoys seen here, which were also sampling in situ points. To analyze the collection and the multispectral data that consisted of a green, a red, an infrared, and a red edge bands, we converted the DN values to atmospheric reflectance using the ArcGIS Pro tools, which also facilitated accurate referencing. A UAS drone equipped with a specific sensor was captured the calibrated panel photos for each band to adjust the correct ground reflectance. To isolate the required data, we outlined the area of interest with polygons and applied these band images and computed the reflectance values using also the raster calculation tool in ArcGIS Pro. Our data sources include in situ measurements and UAS drone imagery. Then radiometrical calibration and index calculations were performed also in ArcGIS Pro ensuring an accurate representation of the Turedians. The 7 different indices we analyzed were the NDVI, the NDCI, the GR, the 2PDA1, the 2PDA2, the 3PDA1, and the 3PDA mode. Using also the ArcGIS Pro raster calculator to correlate chlorophyll A levels with in situ data. The NDVI, for example, calculates vegetation density and health from red and near-infrared wavelengths, while NDCI and other indices offer insights into chlorophyll A concentration and vegetation state. Finally, we employed leave one out cross-validation using the R tools to assess the predictive performance of our model across all indices, integrating statistical correlations via the Pearson method to gauge the linear relationship strength between variables, thereby refining our analysis of chlorophyll A levels in the water column. We then tested these results through doing firstly a Taylor diagram. Each model uses a different index, as you can see here, for the estimation of chlorophyll A. Model 1 used the NDVI, Model 2 the NDCI, Model 3 the GR, Model 4 the 2BDA1, Model 5 the 2BDA2, Model 6 the 3BDA1, and Model 7 the 3BDA mode. So as we can see for observing the Taylor diagram, none of the models are particularly close to the point marked here as observed in the x-axis. That is showing that they agree more with the in situ data that we collected. It can be seen also that Model 5 and Model 7 are the closest to the observed value. Model 7 in particular has a bit of a smaller RMS error, which can be seen here in the lines. But Model 5 has a slight higher correlation with in situ data and a closer standard deviation with the observed data that we have. All the other models seem to be too far from the observed value and have way too small correlations to be considered fit. So clearly the 2BDA and the 3BDA mode indices work better than all of the rest. The selection between them might differ depending on what specific requirements each study has or application. So in this case, Model 5 seems to be working better and be a better choice because it has a stronger correlation with the observed data and a good consistency as detected by the standard deviation. Then we also carried out statistical correlation diagrams between each of the indexes and the chlorophyll in situ data that we gather. They illustrate the relationship between each of the indices and their correlation. Notably, the indices exhibiting stronger correlation with in situ data seems to be again 2DBA2 and 3DBA mode. With correlation coefficients of 0.4219 and 0.4264 respectively. This is evident not only from the correlation coefficient values, but also from the steepness of the statistical lines and the proximity of the data points to each of the indices compared to all the others. The result of the correlation of the indices shows promise to moderate correlation coefficients and indicate a significant relationship, but of course with room for improvement and refinements. Concluding, this analysis serves as a basis for further exploration into the factors affecting chlorophyll A concentrations and the development of more accurate models for predicting these levels in aquatic environments. It also serves as a very good tool to exterminate the cost-effective and time-consuming process of sample taking for scientists. Thank you very much.
Thank you, Ms. Papageorgiou, and for staying within the time limit. Do you have any question from the audience? You can take the question, Professor Vellegrakis.
Yes, thank you very much. Just a question, because I'm sorry, maybe I was for a moment out, I didn't hear. The in situ data were from the same area, were from other different areas?
Yes, they were from the same area, the ones on the map. The 6 boys, we took the aerial photographs. These 6 were the sampling points.
And the conditions?
We tried for them to be good because initially we also tried to gather satellite data, but
I'm just saying that, have you measured the conditions like salinity, temperature, this kind?
The conditions, the weather conditions.
Yeah.
But we only measured the chlorophyll in this particular case.
Okay.
We didn't take any other factors.
Okay, thank you.
Thank you.
If there is any other question from the audience, I would like to ask you one. First of all, due to your results, did you find any specific wavelength that was more useful in identifying that shows a closer correlation with chlorophyll A from the in situ data? Based on these indices that showed were the most promising.
Yes. I think the bands that we used specifically in the indices were bands that could be detected from what we have the multispectral tools we have to take the images. So maybe they're better ones, but the ones that were used to calculate the 2BDA2 and the 3BDA mode indices were, of course, the better wavelengths, I think.
And the last one, during your, if you remember when you were doing your bibliographic research, if you found any indices that you that were promising in similar applications, but the available camera didn't have the specific bands or wavelengths that could be used. It would be, I think it would be nice for everyone if you have this information to give it if anyone is doing a similar application.
Yes, I forgot to mention, but all of the indices I found were from the references that I took were from similar studies that were taken for research purposes. And I think, of course, we found a lot of indices, but these were the only ones we can use. So me personally, I don't specifically remember any others because we focused on these ones and it was kind of a long time ago. Sorry.
Okay, thank you very much. Is there any other question? Thank you, Ms. Papageorgiou. We can move on to the last presentation by Mr. Stathouras. He's here in the audience. The title of this research is Absorption Kinetic Studies of Methylene Blue Dye onto Various Carbon-Based Absorbent Materials. I'm sorry for the time that's taking. We can't find the presentation within the system. You'll give us a few minutes to handle this. Okay, found the presentation. We can, Mr. Stathouros, when you're ready, you can begin your presentation. Sorry for the delay. Okay, so first of all, sorry for the inconvenience. It's been an honor and pleasure to be here with you. So let me introduce really quickly myself. My name is Stathouros Arion, and I'm an undergraduate student from the University of the Aegean and the Department of Oceanography and Marine Biosciences. Before I commence the presentation, I'd like to thank especially Professor Vagui and Professor Petsas for their help and their guiding through the conduct of the experiment, and also the Department of Geography for handing us some basic equipment that we needed during the experiments due to some malfunctions of our own. So this is what is ongoing experiments. I'm not done yet. I have several more to do. I'm going to do a small briefing. It's basically the adsorption kinetic studies of methylene blue on several carbon-based materials. And small briefing. In modern society, we have a large number of organic compounds being disposed into the oceans. Some of them, we have to underline, that are non-biodegradable, which can cause easily various ecotoxicological impacts. So taking this into consideration, and with the little scientific research and literature we have, it was observed that the last, let's say, 10 or 20 years, adsorption seemed a really good solution to this problem, a really promising alternative method.
So what we actually did was, the main focus of my thesis is the utilization of some carbon-based materials, which I'll explain to you in a bit, in order to see their absorption efficiency from methylene blue solutions. Because we actually see during the experiments that the mixture that we created with methylene blue was absorbed really strongly, and in really seldom cases it was dissolved back into what we created. So, as you might easily understand, it seemed appropriate to carry out such an experiment, considering the removal of the disposed organic compounds and being crucial to marine and human lives. Let's begin with the materials and methods. We use the spectrophotometer to structure a calibrated standard curve for the with this spectrophotometer. We use pH meter for, of course, pH measurements. Some carbon-based materials. Hold on a bit, I will explain to you the three categories that we used. Methylene blue dye, which is basically, it's really simple. It's an organic compound worldwide used in companies for dyeing silk and fabric. And the equipment that we borrowed from the from the Department of Geography, the horizontal shaker. Here you can see the chemical structure of methylene blue and the absorption spectrum of methylene blue measured by our spectrophotometer. Also, I have to mention that during the experiments, we had around 20 to 23 degrees Celsius. So what did the mixtures consist of? So basically, they consisted of 100 milliliters of methylene blue solution prepared in ultra pure water. We have, as you see here, several flasks with a range of concentrations. Here you can see if it's, I think it's barely visible in the tip of the flasks. We had each concentration in parts per million. And we also had 0.5 grams of carbon material. We had three categories. Activated carbon, which some of you might know, some of you might not. It's like a form of processed carbon, which has a low, small volume pores and greatly increased surface area to be used in adsorption experiments and furthermore to chemical reactions. And what we actually did when we prepared the mixtures, we placed them into the horizontal shaker. Carefully, we sealed them with film in the tip, and then we left them shaking in 300 rounds per minute and checked them every 10, 20, 30, 60 minutes, and then at 90 minutes, 120, and 180 minutes. So moving on to the results and the adsorption, isotherms, and kinetic experiments. Here in the graphs, you can see the contact time for maximum adsorption for each one of the three categories. First of all, in the A, you can see the contact time and maximum adsorption of activated carbon, the carbon prepared from thermal carbonization of olive waste, and the third one, carbon prepared from pyrolysis from waste tires. So as you can see, it's visible that in the first one, we had the maximum adsorption at, let's say, 1 hour and 45 minutes. In the second one, it was around 2 hours. And in the third one, it was in 3 hours. So based on the acquired experimental results, we observed way faster process from the activated form to the other two non-activated forms. In this moment, you could easily question yourselves, or maybe interrupt by asking me, why did this happen? What did this occur during the experiments? So the theory is that it might happen this may be attributed due to the lack of efficient number of active spots for the adsorption to take place. And then as we continued the experiments, we saw that we had some problems with the third category of activated with the carbon prepared from pyrolysis of waste tires, because after the removal of methylene blue was decreasing with the increase of time. So it was like contradictory to what we wanted, because the desorption was happening way faster than the adsorption. So no further studies are conducted at the present time, and I think they will not be continued. Here we have some adsorption isotherm models and coefficients. In the first one, you can see how the molecules of methylene blue are distributed between the liquid and the solid phase when the process reaches the equilibrium state. And the other two figures show you the plots between the methylene blue that was absorbed versus the equilibrium state, the equilibrium concentration of methylene blue dye in our solution. So with the data that we had, we used these two models that can easily describe the kinetics of the occurred process. The data, it's the state that I am working right now. The data fitted perfectly into the models, and we try to calculate the isotherm constants and the maximum absorption that we have from the two categories left for our experiments. And I have to underline that both substrates have a strong affinity towards the absorbed organic dye. Thank you very much for your attention, attendance, and patience.
Thank you, Mr. Stathouras. Is there any question from the audience? Okay, this research is very outside of my research area, but I would like to ask how this could be used for management purposes, how this research could be used in management purposes, if you have anything to add. Open your microphone, please.
Do you hear me? Yeah. Okay, so this could be easily used into trying to cleanse, let's say, the oceans and water, to basically decontaminate it. I think that's the only use of it right now. As of what I've understood through this, it's like an ongoing experiment, as I said a bit earlier. So I have several experiments to be carried out.
And do you have any idea if it can be used in in wide areas like coastal areas, or it's more useful for lagoons and smaller water bodies?
Yeah, it's basically for the second category that you mentioned, exactly.
Okay. Is there any other question from the audience? I don't see any raised hands, so thank you, Mr. Stathouras. And with this, the final presentation, we have finished our session. Thank you very much for your attendance, everyone, and for all the attendees for staying within the time limit. I think we can continue.
Just to remind to everyone that in the other building, at the building of Oceanography and Biosciences, at the third floor, there is a room where all the posters are displayed in 3 different screens. So during the Congress, please find the time and on your way to go to the third floor and see also the very interesting e-posters. Thank you.